So I have the amazing honor and pleasure to be with Michael Heke. He's a PhD and he's the Chief Scientific Officer at Regeneration. And what we've been talking and we've been researching and we're brainstorming for, I don't know, a lot of years now, I don't know, 3-4 years, is about how we can make sure that people live longer, healthier. And after us researching and analyzing and trying to hack with all the analysis that we do for blood tests and for the exosomes, how they work, we've realized that we would be able to do it in combining a variety of interventional modalities. Mm-hmm. And you can see he's taking good care of himself. And I love people like that because they don't only preach, but they practice what they preach. And you can see he got the Oura ring so you can monitor the reaction to the different treatments we do. And we've talked, but this is the first time we meet face to face, so it's exciting.
At long last.
Yes, at long last. So can you tell us a little bit about yourself and your the path that brought you into this kind of area?
Mm-hmm. So I started my career in pharmaceutical research, actually, pharmaceutical industry, working for Bayer for long years, and then I did educational studies, first in mathematics, then chemistry, and then I switched back to biology.
Wow.
And eventually I became a stem cell biologist. I'm doing stem cell research for over 25 years now, and I soon became fascinated with the potential of stem cells for the purpose of regeneration, regenerative medicine. So I focused on the translational potential of stem cell research into practical applications. And that is something that I'm pursuing for over 20 years now. And over the last couple of years, we are focusing on what I perceive as the next evolutionary step of stem cell therapy, which is exosome therapy. So these exosomes are tiny little bubbles that get secreted by the stem cells. And they are the means or the tools by which stem cells actually render their benefit. They're very powerful by their content. The cargo consists of growth factors, cytokines, and other functional proteins, lipids, metabolites, and microRNAs that comprise the genetic information on how to reboot a cell. So unlike all the palliative treatments and symptomatic treatments that we know and are so efficient, exosomes work in a different way. They actually fuse with the target cells, then infuse all their cargo so that the cell has all the building blocks and the genetic information to reboot and reprogram itself and return back to a more youthful state. And there you go, not only applicable for regeneration of sorts, but we might actually have a tool to pursue longevity, that we can turn back the clock a little bit and halt aging, partly reverse it. It's very promising, and this is my first infusion, thanks to you. So
my pleasure.
The pleasure is all
my pleasure. Well, thanks to you. I'm doing that stuff too,
and I'm longing for it. I do this for years now, and it's indeed my first infusion. I'm very excited to see what comes up.
That's right. So what we're doing is we're doing the methylation test, and the methylation test is the most accurate method in order to identify the biological age. We'll be able to evaluate the biological age for different organs. Now, methylation is a methyl tag, it's carbon and 3 hydrogen that is attaching to the DNA, actually to the histones, to the protein that controls the unlocking of the different DNA genes. And what happens as we age is that you get these methyl tags, and they're basically like very strong chains. Please correct me if I'm wrong, because you know the stuff better than me. They chain the gene in such a manner that it's very difficult to remove it. So you can have acetylation, which is a different type of binding to the histones, and that can be reversed. But methylation is very tough to reverse, except with the use of the exosomes. And this was proven by Carla with the proteomics that she did at Harvard, that it actually does that, because for a while I was talking about that it can do it, but we needed the proof. And your lab actually did it. You guys proved that it's actually scientifically does that stuff with the cargo that you were talking about. So when you reverse this unnecessary opening of the DNA that leads you to aging, you're able to reverse the process of aging. Now, when I'm saying leads to aging, there's no really gene that causes aging. But what happens is your genes have to do their program. Imagine you're trying to talk to your son about something, and he's talking to you and suddenly he's on his cell phone, talking to friends and texting. That is interrupting. That prevents you from being able to communicate with him, takes extra time, takes you effort, takes you stress. The same thing with the genes. They're supposed to produce the special protein that are necessary for that cell to function properly. And then suddenly, here comes another DNA that is opened and is stuck right in the middle of your pathway, and you cannot produce the necessary protein without producing other proteins that are unnecessary. And so you're finding to clean them out of the system. It takes a lot of energy, a lot of power, a lot of time, and your body gets tired. It gets tired and has to then decide where to allocate its energy. And that's why what we're doing is, besides doing the exosomes, in order to make your body able to sustain the benefits that the exosome provide, we also offer the NAD. And the way I look at NAD is I look at it as the fuel your body needs in order to be able to handle the necessary requirements that it is forced to handle. So if, for example, you imagine my day, my life feels very stressful, I tell people it's kind of like every morning I'm driving from here to Washington, D.C. and back. It takes a lot of fuel. If you only drive to Manhattan, it takes you less fuel. So if you need more fuel, you'll need more of the NAD. And if you don't have it, you'll get stuck in the way. And you don't want to get stuck in the way and look for, other modes of transportation. So in order to do that, you need to make sure that you have sufficient amount to handle your stress. Now, how do we know where is your proper NAD levels? And that's amazing, because 6 weeks ago, there was another test that was developed. Because we know NAD is produced from vitamin B3. It's synthesized from nicotinic acid, nicotinamide. It gets eventually into NR, NMN, and NAD. But in order to avoid those bottlenecks that occur due to the inefficiency with age of the enzymatic transfer of those substrates, the vitamins, into the eventual product, the NAD, what you're getting right now, we can right away get into the final product, the NAD. But to test it, it's amazing, because we have right over here, we have this special test. What we do is we take a little drop of blood, then we, in 3 hours, drop the fixant onto it, and we send it for a test, and we can find exactly the true level. So what we're going to do is we're going to show it to you afterwards in 1 month. We're going to repeat it, and we're going to see how good it is. And also, we're going to make sure that Dr. Heke will also take the supplements, the NMN oral supplements as well. Now, when you take the supplements, the issue that I found with myself is that the absorption is erratic, and you cannot really depend on how well you will absorb it, because it will depend on your microbiome, it will depend on other issues, and also it's related to how fast you need it. One of the nice things with NAD is you cannot overdose, really, because in 24 hours it comes out. It's not like other vitamins like vitamin D or vitamin A that builds up in your fat cells and then are released, and you can have toxicity if you overdo it. With the NAD, in 24 hours, it's kind of like, here is your pocket money for the day, and then you're done with it. So you can't really overdose on that. Question to you. We're going to also do the exosomes, and we'll show it to you later that we infuse the exosomes. Not doing glutathione today, because we're going to see the blood work. And then the glutathione is the #1 most effective antioxidant, but we're going to see that later. And we're going to do right now the test for the DNA methylation, and we'll show you how it is. I use the one by Elysium. It's a simple one. I've been using it forever and ever, and that's why I like to still use it. It was one of the first that was invented with collaboration with Yale University. And the way it's done is you have to make sure that you don't brush or eat or drink 30 minutes before. And then what you do is you just spit into this, and you can go ahead and spit into this in the meantime while we are doing it. And enough in order to make sure that we get to that white line. What is better, to do stem cells or to do exosomes?
That's a tough question. The gold standard today, I would say, is a combination of both, but also depending on what you want to treat. There is no serious difference other than the fact that stem cells are by default viable. So if you transplant or infuse stem cell, they can sense their environment and adapt accordingly and be a little bit more specific. so they can react to the environment. The exosomes are just inert tiny bubbles. They are not living entities, so they are not cells, and therefore they are what they are. And they do actually all the work, and you can apply them in very, very large number. So you are less limited by this because the body doesn't recognize them as something foreign. You have no immune rejection. For cells, because they are much bigger and they are living beings, it can be a little bit different. So they're also immune privileged. So typically you don't have any immune reactions to it. But the body recognizes that there's something invading the body, so to say.
Sometimes a little fever they can have or something.
Yeah, it's very common that you have like maybe a mild headache, a short temperature raise in blood pressure or heart rate. It's just temporary. It all goes away within 2 hours max. But
also depends where you infuse it. If it's in the spine, it's much more. If it's in the IV, it's much less.
Exactly.
Right.
And for exosomes, they're so tiny, like they're nano-sized, so you don't have this. They go in and they're not really recognized, and you can apply them in very large numbers depending on what you try to address. And that's the one thing we still have to evaluate, the dosage and the frequency to gather optimal results. And that's why we're here today, to actually, for the first time, really assess that in a small clinical trial between all of us, to assess what a particular treatment regimen can achieve, and if we can go lower, higher, more often or not, and how it actually pans out over time. So this is very exciting and bringing the field a lot forward.
Now, a lot of people are saying, okay, well, can you evaluate independently just one thing at a time as opposed to many things together? The answer to that is, in life, it doesn't matter how you may try to make the experiment pure and only have one variable. Since we're dealing with humans, there's a lot of variables. You may interact with someone in a negative or a positive way. That will affect your biomarkers. And that will affect other things. You may sleep better or worse, and that will affect your biomarkers. So saying, well, you did not only the exosomes, you also did NAD or also glutathione. Our goal is to get to the end road. End road is live longer, healthier, prevent cancer as opposed to react to cancer and treat it. And cancer, we know, is our own cells that are going array. If we give our body the necessary tools in order to repair the mutations in the DNA before they become irreparable, before they're taking over our body, before they become cancer that does not listen to our orders, then we can live longer, healthier, and concentrate on better things to do in life. And people are concerned about longevity. I think David Sinclair in his book Lifespan answered their hesitations or concerns much better. We should not be worried about people living longer. We should be worried about how people interact with one another, how they respect one another. And by the way, shout out to my children's book, The King's Race, that is just out today. This was my goal. My goal as a physician, and people ask, how come you're a physician, you also write a children's book, is to try and heal people. And the best way to heal is to try in the root. Just like we're going back with the exosomes to the root of what directs our health, we also need to go to the roots, what lets children have the necessary mindset in order to grow like a tree that is able to handle whatever comes in life. So once we're done with that, what we're doing is we activate it with a fluid here. So we're going to close this, and the fluid from the top will come down. And after the fluid from the top comes down, we'll remove the cap and put the new cap on. We'll just throw that out. We'll screw this cap on. Now, while I'm doing that, can you tell us a little bit about, is there any danger of using exosomes? Anything that you can imagine that could be potentially harmful or should be of a concern to someone?
No, not really. So there have been reported as extremely safe. There are no serious adverse events that I'm even aware of in the context of any kind of exosome treatments, provided that they are sourced properly. So you gotta be careful about your providers. There are, like, I think at this time, 200 companies out there that...
How many?
200.
Oh my God.
That sell exosomes, but most often the sources are dubious. They don't tell you where they got their exosomes from. You don't know how they are manufactured, and most of them come without any certificate of conformance. So you should do your due diligence, but provided you have a powerful source, which is typically mesenchymal stem cells from perinatal tissues like placenta, umbilical cord, or jelly, or amniotic fluid. These are all suitable sources, and they are the youngest stem cells that we can get our hands on, right?
That's why you guys call it H0. I love that.
Exactly.
Very
and
smart.
they just finished building a new human, right? A healthy young baby. And you utilize the power of those stem cells to derive your exosomes, and they are responsible for cell-to-cell communication and can therefore affect all that we hope for.
That's right.
H0 is a very good pointer. Yeah, that's key.
So that's very good, important point, because people don't understand. It's not only the exosomes. It's kind of like, I want to see a doctor. It's like, okay, there are a lot of different doctors. I want to see the best doctor. The same thing, you want to do the best exosome. So going to a doctor sometimes may make it even worse. He may give you the wrong diagnosis, the wrong treatment, and will bring you to the death. So the same thing with the exosomes, and therefore I have also same story with Botox. Oh, why did I go do Botox? Now I have a skin cancer. No, you didn't get skin cancer because you did Botox. You had skin cancer. The person who was giving you the Botox didn't recognize the skin cancer and injected you over there, and so you had the reaction there, but it wasn't from the Botox. So when people come and tell me that, and those are real stories, I tell them, no, you misunderstand. You need to go to someone who knows what they're doing with specialists if you care about your body. So it's not about saving a penny here or a penny there. It's about the long-term goal. And when I was looking at different companies, and I've dealt with many companies, it's very nice people. The issue is not about the people. It's about the lab. And you have to make sure that they allow you to look at their work at their lab, and when they're hiding it, there's something there to hide, and there's many excuses why they claim that they need to hide it. All of them are baloney. And the other question is, how do you explain also the numbers? So you have billions, trillions. Where do those things play a role? And then there are those exosomes that are lipophilized, not lipophilized. Can you explain a little bit about that stuff, because doctors are also watching, learning, listening?
So those findings are still something in progress. When we first started out, it was topical applications for skin rejuvenation, and in the field there seemed to be a standard of taking like 5 billion exosomes. We did a dose response study. We did like 5, 50, and 100 billion on over 100 patients and tried to assess. And it turns out that the higher the dose, you might have like a marginal higher effect, but given that we have a defined surface area, there's only so many exosomes in one go that can be taken up by the skin. So you rather opt for a higher frequency and a relatively low number. So 5 billion seemed okay. We did 10 billion for a while. So you can expect something like this. Same for, we do an infusion now. We do a really high number to establish the proof of concept first. And after that, you would do like a dose finding study. We like lower the numbers to assess what is the minimum number to give you a good result, and then do it more frequent than like a very high number, because it's also a matter of pricing and everything.
Correct. So that's the goal. We're trying to find for you the best potential price so that you can achieve the result with the minimum cost. Another question I have, and that's a tough question, is imagine someone has cancer. And I know cancer is a general term, and not all cancers are the same. Others would use the same treatment for all cancers. Are there certain cancers where exosomes may be actually detrimental?
Not that we know of. So we have seen them applied in the context of various cancers, kidney cancer and others, and we have seen some benefit, but the mode of action is not quite clear. So it's like a hopeful approach, but we have to figure out a little bit more about how that actually works to maybe define the treatment regimen more clearly. They cannot do any harm really, because they are supposed to support healthy cells.
You want to tell me that on the cancer, there are no receptors that would want to accept the exosomes?
Correctly, yeah.
Interesting. We haven't found cancer that has the receptors to accept these exosomes.
You have to imagine exosomes are very...
But cancers also produce exosomes.
Yes, that's correct. So exosomes are very specific to their source. So if you have a mesenchymal stem cells that just build a human baby, so that's the designation of those exosomes. That's what they do. Their task is to actually regenerate and develop tissues. If you have a cancer stem cell, they do exist. They, of course, are different because they are expected, the exosomes secreted from those cancer stem cells, they are expected to actually promote tumor growth. So they have different tasks.
But I get it. But if you have them lyophilized, then you're saying the growth factors, those growth factors can make the cancer grow.
They could potentially, yes.
Could, because we know, let's say, even the Regeneration gel that we were using, there was a concern, don't use more than 30 grams because you can potentially increase cancer, even though you're applying it topically, internally, because it's platelet-derived growth factor beta.
Yes,
so
that's a concern.
Yes.
It's not sufficiently proven, but it is a concern and has to be taken seriously.
Right.
But for bioactive intact exosomes from the right source and properly manufactured, there's no indication that they could be harmful in any way. They are acellular, they do not carry DNA, so they cannot replicate and they cannot cause or promote any tumors.
Gotcha. So again, they carry microRNA, they carry lipids, and they carry
metabolites, certain vitamins, and a whole set of functional proteins that are all known growth factors, human growth factors, and cytokines, chemokines, these kinds of things.
Right. And you guys actually are the ones who did that research on the proteomics. Is that available for everyone to kind of see?
It is under preparation for publication, but you can contact the company and we'll be happy to provide that information.
Wonderful. Yeah. That's amazing. This is so informative, everything you've said. We're doing stem cells, as you know, for people with MS, which I found was the hardest thing to treat. We've done that for people with skin cancers, and I've had one basal cell skin cancer that went away just from exosome injection.
Crazy. Yeah.
Yes.
It's amazing. I mean,
yes,
just from exosome injection.
Like it's one case. Yeah. The other case, she left back to Moscow, so I couldn't re-biopsy her. And we've injected people with melanoma where nothing else helped. So I think when people are saying, did it help, did it not help, it's also the stage of the tumor.
Absolutely, yeah.
And so you may be living longer because, as you said, the cancer is trying to take over our body and you're giving support to our body. It's kind of like the US supporting a fledgling democracy trying to fight against terrorists, but, it's just supporting it, They still will not win if the forces against it are stronger. So depends how early your intervention is. So it's important to prevent if we can, which is what we're doing.
The better, yeah.
Would there be some tests that you recommend they do before they consider stem cells or exosomes?
No, not really. I mean, definitely a general health assessment is good. It is possible that some patients reactive sensitive to stem cell treatments. But again, even for MSCs, provided that they are sourced and
mesenchymal stem cells MSCs
properly, then there's nothing reported in the literature which would cause any alarm or concern. It's really just those minor things, like a mild headache, temperature.
Right.
Sure.
I've never done stem cells for myself. Now, question to you the following. In Russia, in the Soviet Union, there have been a lot of people, and I remember doctors coming to me and saying that they're doing stem cells. And they looked amazing. They looked very young. And then 20 years down the line, they started getting weird cancers, ITP, idiopathic thrombocytopenia purpura. And I was telling them, you know what? I don't want to do that because I'm taking a foreign element and I don't know how it will potentially change and affect me. I'm going to be hanged shortly with the patient. But what did they do wrong? Let's put it this way. What did they do wrong that we are believing that now we're doing right and it will therefore not happen to our patients if we do? I mean, maybe they overdid it. Everything has to be in balance. Yeah. Maybe they did too much of the stem cells. Maybe the stem cells came not from the stage zero.
Yeah. That's what I would suspect. So I'm not sure what the source was, and the manufacturing protocol and so on. That's really finicky to actually come up with a clean medical product is not trivial.
Right.
So
you should see their lab. Insane. Yeah. I've never seen a lab like that. This was absolutely magnificent. I mean, not a penny was conserved. Everything was done the way you would dream in, I don't know, 300 years from now, hopefully. This is insane.
We did it with a lot of passion, and we always had ourselves in mind and our loved ones. So
Correct.
what is it?
And
we
they
want
are
to see?
all using it.
Yeah.
They are all using it in their own family.
That's how I actually joined. I'm a stem cell biologist, and I first interacted as an advisor. What are the key scientific things to observe and so on. And then I became fascinated with how diligent they really approached everything, and with the passion behind it. It was not created as a business per se.
Right.
They saw something in it, and the business was a side effect. It was the poster child of doing well by doing good.
That's amazing. I love that. I love that.
That's what made me committed to the companies.
Yes, I can see in your eyes. You got that glistening eye for excitement.
Oh, yeah.
I love it. That's what makes me happy too. That's why I love working with them.
You're a passionate person that I've ever worked with. So it's truly a pleasure.
Wow! What a compliment! I don't deserve it. I will work hard to
you do.
make your kind words worth.
And also the joy you bring to the table. Obviously, you believe in what you're doing.
Well, yes, we believe in that, and I am always telling people that no matter what you deal with, you always have to look at it objectively with a scientific mind, and never allow hype or fear or panic to dictate your decision. Same thing is how I handled with COVID. Everybody said, "Oh my God, Levit don't work." Instead, what I did is I put UVC system everywhere, filtration system, developed it with a team. We invented some patents in it, improved it, and we didn't stop working. We worked the entire time, and my wife even was telling me, "You're not going to come home. You're not going to sleep at home. You're going to sleep outside." And one of our children was a little bit, you call it hyperactive airway disease instead of calling it asthma, but she was like, and at that time they were saying they're susceptible more. I'm like, look, I learned about infection control. This is not anything different. We should not panic. We should continue to offer people help if they need it. And I'm just a dermatologist, but I was still doing stuff. It was like, oh, suddenly melanoma did not have to be removed. You can wait 6 months for melanoma. I mean, guys, give me a break. So many people died from cancers because they couldn't be taken to the hospital. Instead of thinking with minds, they were thinking with fear. So being able to work with you guys, with and playing with your imagination and listening and getting excited from your creativity is a blessing.
That's what we have in common. We have a solid foundation of knowledge.
Correct.
We see an opportunity and potential, and then you have to pursue it. Hunt it down to actually make it work for everybody.
I agree. A few things I want to say is, if you want to get more information, it is Resiliel, the company, RESILLE. So the double L is the last double L.
Just reach out and
reach out or send to me or to Professor Michael Heke or to me at Levit Dermatology or Levit on the Instagram or the office 718-375 skin SKIN 7546. The idea is, again, we believe in checking biomarkers before we start, because besides just thinking that we're doing better, which there's a very strong placebo effect, we want to objectively prove it. And that's the right way of doing it. So that's why we're doing the NAD levels, we're doing the methylation test, and we will repeat it. And we will share with you the changes when we repeat it in a month after we do the infusions. And we'll get the pleasure of seeing you in a week.
Absolutely.
All right. Thank you.
Very much looking forward to it.
Thank you. If you want to tell them something else that you think would be interesting, please let them know, either about the stem cells, the exosomes, the ingredients in the proteomics, or and anything else that differentiates, because I know we didn't talk about that, but besides, people say, 5 billion, 10 billion, 1 trillion. Besides that, there's other factors, and not all 5 billions are the same 5 billion. So maybe you can say a couple of words about that.
Okay.
If you don't mind.
No, I'd be happy to.
Pleasure.
Thank you so much.
Thank you. Thank you, guys. Keep listening.
It's really important to vet your providers and ask a few tough questions, because not all exosomes are created equal. First of all, the source. I think we already conveyed that stem cells are the most promising and suitable source for exosomes when we want to apply them for regenerative purposes. The reason is that stem cells are by default the building blocks of life, and they are not only supportive but also responsible to fix things as they arise. Unfortunately, with age, we lose most of our stem cells, so there are never enough left in our bodies to deal with how our bodies get compromised by environmental hazards like toxins and chemicals that are all around us, disease, bad food, and aging, of course. So stem cells are definitely the most suitable source for any regenerative purposes. Then you might have heard about bone marrow or adipose tissue-derived stem cells. They are a source, but they are not the best source for two reasons. First of all, they come from adult donors, and these adults have been subjected to sad environmental hazards for all their life, and they might have even accrued certain mutations into their genome, which modifies the potential of their stem cells. So it's not the ideal source. The ideal source is really perinatal tissues, placenta, amniotic fluid, and the umbilical cord. And within the umbilical cord, there's the so-called Watts jelly. It's a gelatinous tissue that gives the umbilical cord its crunchy texture. And within those, you find a lot of mesenchymal stem cells that are immune privileged. That means they don't have the surface markers that would expose them after transplantation to the body, that they would know it's a foreign entity and has to be attacked. That makes them very valuable, but they are also the youngest mesenchymal stem cells that you can harvest. And there's another, we mentioned H0, which is a very interesting concept. The H0 designation means that these were actually created before the baby was born. And the reason why this is very interesting and important is that while we are still in utero and under development, basically everything that goes wrong or could go wrong can be fixed by those stem cells. As soon as we are born, the nature decided development is over, and we lose that capacity for absolute regeneration and repair. We still have regeneration potential, obviously, wound healing and so on, that diminishes with age, of course, but we do have these mechanisms. But the absolute regeneration is no longer possible to fix everything. One of my favorite experiments was rat embryos. Before they were born, they inflicted cardiac infarction on those rat embryos, and a lot of cardiac tissue dies off and is replaced by scar tissue. That's what would happen to us if we have a cardiac infarction. And then you live with your scar tissue, and that renders the organ still functional, but less so than it was before. However, if something like this happens before you're born, the scar tissue gets replaced by fully functional and normal tissue. So that has been shown in rat experiments. So that's what I call total regeneration and repair. And this is unfortunately getting lost after we are born. But utilizing those stem cells that were actually produced before the baby was born, we harness that regeneration potential for absolute regeneration. So it's the highest potential of regeneration that you can find anywhere. And that's why perinatal tissues are the one and only, or the gold standard when it comes to stem cell or exosome therapy. So this is very important. Then secondly, we touched on lyophilized exosomes. They are unfortunately no good. It just affords shelf life and ease of shipment because you don't have to ship things on dry ice, but you buy it at a high price. So the exosomes unfortunately get destroyed in the process of lyophilization and therefore cannot function as we want them to. Then the numbers, again, source is important, that they are never lyophilized but come in a native, frozen fashion in saline or other buffers, suitable buffers. And then the numbers game. You will find that a lot of companies starting to sell very high numbers. Instead of 5 or 10 billion, they all of a sudden give you 1 trillion particulates. Whenever you see the word particulates, just stay clear of it. Particulates means that they are utilizing stem cell media at best that is no longer purified, that it's not defined, that it's not characterized, that it's not tested. So nobody knows what's in there. And yes, they might have also exosomes in there, a few. You might even see a benefit. But it's basically throwing the kitchen sink at you, and it's just to save money and to impress you with higher numbers. So whenever a provider is talking about particulates, be aware that this is like a non-defined entity. You don't know what you actually get, and therefore it is just not good. There is something that's called the Exact Oversight Bureau. Exact stands for exosome, I think, analysis and conformance something. You will find them on the internet, and they are a very good source. They actually made it their mission to vet providers, to test exosomes, to assess whether an exosome product actually has exosomes at all, which shockingly is not often the case. They can advise you and provide references as to potential of exosomes and so on and so on. So if you're in a pickle and you have questions, contact the Exact Oversight Bureau, and they will happy to share all kinds of information with you. Contact our company, contact Dr. Levit, and if you are interested in products from other providers, always ask tough questions. Never settle for a product that's not thoroughly analyzed and validated, that doesn't come with a certificate of conformist, that doesn't show electron microscopy pictures that confirm the integrity of the exosomes. Nanoparticle analysis is also critical. A lot of things, and our certificate of conformance is over 20 pages long. So this is something that you should insist on, including third-party testing, and then all the bells and whistles that the FDA demands. So even if you have topical applications for hair restoration or skin rejuvenation, never settle for anything less than a medical grade product. And then you should be surprised and amazed and pleased with the results of exosomes and what they can do for you. Thank you for your attention.